And after this meeting, everybody will receive a link to this recording so you can view with you and your crew if you want to at your convenience. Ionics gas technology, our goal is to improve safety in the natural gas distribution industry by suppressing static. We invented the topical anti-stat used in O&M operations. Plus, our interior static suppression system is designed to prevent grade 3 leaks. But this isn't about static. This is about a man who I heard speak at the Alabama Pipeline Safety Meeting in December, and that's David Bullard, Lieutenant David Bullard, Columbia County, Georgia, Fire Rescue. But David has an unusually good background in natural gas response. He comes with a viewpoint from the other side. And I sat and listened to his presentation at the Alabama Pipeline Safety Meeting. And I said, this is something that I need to bring to operators around the United States who might not be able to view David. He'll be speaking at the AGA meeting biennial coming up. But if you can't go to that or aren't a party to that, you're going to have the opportunity to benefit from his knowledge with this webinar. I would ask you hold your questions to the end and chat them in at the end. We'll go as long as you want to do that. David is going to provide you his contact information in the front and in the back at the end of this meeting. And one last thing, I just want you to be gracious to us. David and I are not professional Zoom presenters. So if we stumble a little bit, I want you to be gracious to us because we don't do this for a living. Our job is to try to eliminate static and coordinate emergency responses and not run Zoom meetings. Okay. Now let me see. I got a chat. Let me make sure I don't have a problem. Okay, we're all set. Okay, so what I'm going to do is I'm going to put David in. And there you go. So, David, you're on. Let me make sure I can hear you. Can I hear you?
Can you hear me?
I can hear you.
Well,
so we're
good.
all set. So it's whoops. Bear with me because I'm going to be letting people in. There's still people coming in. So go ahead, David.
So thank you, Dirk. I'm glad to be here this morning. And I always tell people just my bio is I'm a firefighter on the west side of Augusta, Georgia. And I started as a volunteer in a rural community. Our area has grown. I work for a combination fire department now, which means we're mostly career. We still have a few volunteers left. We cover a pretty diverse area. And I also teach in our Georgia Perry program. And I'm with Buxus, and we'll talk about Buxus a little bit as we go. We're an emergency response app for responders and operators to better disseminate information and pipeline locations and information to use in pre-planning and emergency response. And I think the funniest thing, this just hit me a few minutes ago. I was joking with somebody, and I said, well, my daddy's a pistol. I'm a son of a gun. So if you call me son of a gun, that means my daddy's a pistol. And I like that. I just think that's a cool little saying. And I don't know why I threw it in here, but hey, we need some humor to start with. My caveat is this is normally about an hour and a half to 2 hour presentation with some more examples and some demonstrations we do and some conversations we have. So we're going to part down a little bit this morning, but if you would like this via Zoom or in person in an event, my email address is already in the chat. I'll give it at the end to everybody, but it's in the chat now. If you want to go ahead and copy it down, more than happy to work with you on doing such, because I think this is a pretty cool message. Some of this is tongue in cheek. Some of this is kind of serious, and we'll go both ways there. Dirk has put the first slide up here. It's a QR code to download Buxus. If you're an operator and want more information on it, you can reach out to the website, or excuse me, the email address or the website for Buxus, which is buxus.io. And we're more than happy to talk to you about our outreach and what we offer. And for a responder or somebody that would use this on the response side, the app is available through the QR code here. And we'll talk about how the myth leads into the uses of Buxus, or the myths lead into it. So next slide, Dirk. So the first
there
myth,
we go. I'm sorry. Bear with me. Like I said, we're not professional Zoom guys. Go ahead, David. I'm sorry.
Oh, that's fine. That's fine. So when a firefighter or responder is trained, they're given the North American Emergency Response Guidebook to learn hazmat from, their awareness level of hazmat. There's a short section in the front on pipelines. It's really lacking on in-depth info on pipelines, but a lot of curriculums say that there's always a pipeline marker. Well, in transmission, there's probably always a pipeline marker there, but in distribution, most distribution lacks a marker. So that's a myth out there that a basic training being offered says there's always a marker, where I probably can't go into a subdivision or a neighborhood or into downtown of any city. There's not a right-of-way marker all along the sidewalk there. So that is one myth that's out there. And the ERG paints an imperfect picture of that. The next part of that is in the ERG, it gives isolation distances for releases of different chemicals. Particularly natural gas is going to be in there, propane's in there. Most things carried by a pipeline, if not all things carried by a pipeline, should be in there. Those distances are based off of a container no larger than a rail car. Those distances aren't based for storage facilities. Those distances aren't based for a pipeline because they can't account for the volume of product or the pressure of some factors like that. So working with an operator to determine good distances for isolation and evacuation and use of air monitoring become very important. The book may give a start, but it's an imperfect answer when it comes to pipelines. And PIMSA really wants folks to understand on the emergency response side that that book does not give the best information for pipelines. So next slide, Dirk, please. There's a belief out there that 811 can identify facilities. In our Perry program in Georgia, we do a survey, and one of the survey questions is, which one of these things can help you identify a pipeline? Pipeline markers, calling 911, calling 811, contacting the operator, things like that. And for sure, I can call 811 and get a locate, and I may can go through 811 to help identify an operator's location, particularly. But if I were to be unfamiliar, this is about 1,000 feet out of my county in a neighboring county. If for some reason we wound up on this on a call, there's no signage in this facility that says what it is. I can't call 811, identify this facility, and typical mapping systems don't show facilities either. So I may have no idea what this is, and I'm trying to figure it out. And honestly, looking at it, there's a lack of signage there. But there is a belief out there that calling 811 can identify facilities. I happen to know this is a compressor station for a CNG fuel point. But there's nothing there that tells me that. I just happen to know what it is, and not every responder would know that. Next slide, please, Dirk. So there's a belief out there that responders know where pipes are, particularly in distribution. And honestly, there are distribution systems that you don't always know where your pipes are. That's a fact of life. And some have a robust mapping system, and everything is, and some older systems. And I've been on calls this occurred where they were surprised to learn there was a pipe location somewhere. There was a pipe that they thought was inactive. It was still active. That happens. The picture on the left is my daughter. She loves supporting pipeline response and the Call for Your Dig program, and wearing her 811 cape and we're out doing stuff. I assure you, she is not stealing the locate flag there. She is making sure the locate flag is in place. And I think another part of teaching when you do outreach is making sure responders understand what locate marks look like and what the colors mean. That plays into the response. We're talking about migration of gas. If I see green paint, I know there's a sewer close by, a sanitary sewer, or white paint, a storm sewer. And if I have a release underground from boring or something and I'm close to green paint, I need to be aware there's a good chance that the two of them could be intermingling in a migration through the sewer here. The picture on the right is a screenshot from Buxus. This is the gas system in Cleveland, Ohio, and they have came in and they've added the distribution piping into our mapping system on Buxus. With Buxus, the responder gets vetted. They go through a vetting process to be added to the system. They got to be part of a response organization. And Buxus can work with you on how your lines display. But from a responder standpoint, I may go into a subdivision that part of it has natural gas service, part of it doesn't, and I'm chasing odor or gas. It's handy to be able to see where those lines are. I can look and see, oh, there's gas on the other side of the subdivision, and that's to the west of me right now. That's upwind for me. Start going that way to look for this odor source. or in a boring incident, are we on the long side or short side of the street? That's important too. I saw a note in the chat just then. This requires a collaboration from both sides, and that's for sure. And I think as we get into the myths, we're going to hit on that. This is a two-way street. There's a communication that needs to occur in the responder community and in the operator community. My state has been blessed with our Perry program. It has been super successful. A number of other states have Perry programs, and I think one of the successful things about ours is the flexibility of the training. It's delivered on the fire department's time schedule, and it's adapted to what's in their area. And we talk as best we can specific to their gas system, to their transmission lines. We do our best to integrate operators in being in the class, to offer their information up and answer questions and build relationships. And a lot of these things in here are down to building relationships and having a strong communication model there. But there is a belief that responders know where pipes are, and we really don't, right? I can go to any area of my county today, and I can guess what side of the road the main is on, and I may not know. There may be a main on both sides. So as you do your outreach, do your liaison training, think about that mapping capability isn't there. I've been places where the city gas system was able to provide GIS information to the city fire department because they're the same agency. It's easier to share GIS information. Um, it's all about understanding and knowing where things are. We have counties in Georgia where there may be 7 or 8 different distribution operators in the same county. An advantage this would be helping guess which footprint you're on. Of course, you're in doubt, you're calling every operator, and there's nothing wrong with that. But if you identify whose footprint you're on, or if you have multiple pipelines crossing an area, uh, seeing that and knowing what's going on potentially there. Next slide, please, Dirk. So I like to say that we tell some myths or some lies or some fibs or whatever word you want to use when we teach. And I think one of those big ones is we really drill home, respond from uphill upwind, approach from uphill upwind. And at least in the fire service, that becomes a black and white test question. The test question will read, which way should you approach a hazmat incident? And it's uphill and upwind. And that is true, but there are definitely some factors that are going to affect that. The picture on the left is a heavier than air release occurring. So not really a natural gas scenario there, but definitely a carbon dioxide or a propane scenario that if you're releasing on a high point, it's going to follow the terrain. And if something follows the terrain, it can go different in the wind because it goes below the wind level. It moves differently. So that's a big factor that you have to understand. The uphill and upwind may not work together, right? There's always a chance that the wind is blowing uphill, right? You got to realize that, hey, wait a minute, the winds and the hill are not going the same way. I've got to adjust myself there. The picture in the middle is an urban area. If you go to an urban area, you go to an industrial site, um, a manufacturing plant, something like that. The wind around those buildings is doing what it wants to do. It's swirling, it's eddying, it's getting funneled, it's sped up. It is very difficult to determine upwind in those areas because the wind is doing so many funky things on you. And the picture on the right, this is typical of a lot of America. You have a subdivision or a neighborhood or maybe a dead end road that there's one way in, one way out. And uphill or upwind may force you to come from the wrong direction into that. Well, we don't want to drive through our problem. You may have to stop short and walk around. How do you evacuate a neighborhood like that? How do you evacuate a 2-lane road where the problem is between the exit and the residents? Do we shelter in place? With flammable, shelter in place probably isn't a good idea. We want to evacuate. Do we want to have to evacuate people on foot into the woods? Do we have to evacuate people instead of out of their neighborhood to the back of their neighborhood? You know, it's not always as easy as just getting their car and drive off. That could be the worst thing they're doing. And we're also a big fan of encouraging instead of using directions when it comes to describing wind or describing terrain or describing where to evacuate to, use landmarks. If I was in a classroom right now, I'd have everybody point east. And it's funny, I was in Daytona Beach last week. We were teaching at a hotel that was on the waterfront, and I asked the whole class to point east. And I got about three different directions of point from the class. And so, okay, everybody point toward the ocean. And everybody pointed toward the ocean, which if they'd have stopped and thought for a second, hey, the ocean has to be east of me. We're on the east coast of Florida here, right? But a landmark works better. If you want to describe wind, hey, the wind is blowing towards Walmart. The wind is blowing towards the water tower. If you want to give it orders for an evacuation, everybody evacuate from First Street to the YMCA. If you give that, that's a much better and more digestible message for people to comprehend, right? I may not know where I'm at in this town, right? I'm a visitor. I've got the message to evacuate, but if you give me a landmark to evacuate toward, I can probably put that in Google and get myself there. But if you tell me to go north and it's dark, I may be totally lost. But if you tell me to go from First Street to the YMCA, I can put in on Google Maps, see where the YMCA is, and get my way, get myself that direction using my phone. So just some thoughts. And if you're designing a drill or an exercise, or you're having a safety meeting, just play around with that. Ask people to give you direction, then give them some easy landmarks or common landmarks that they may, see all the time, and just see what the difference in the room is. Next slide there, Dirk. Um, I think another thing that we tend to write into safety plans and we teach is to eliminate all ignition sources. And that's our goal. But I think every responder and every person on an operator side needs to be very well aware that we can't eliminate every ignition source. There are ignition sources we can't control, and we have to be aware of that. Traffic signals, I think a lot of people certainly take for granted a traffic signal is an electrical device that if you have a gas leak occurring in an intersection, that traffic signal could be an ignition source. And without the traffic engineering department or Department of Transportation, we're not shutting that traffic signal down. So we either have to protect that, may even put a water stream up to knock gas vapors away from it, or just be aware that this thing could cause an ignition and be prepared for that. On the right, I put the thermostat there because frequently when we go investigate an odor of gas in a building or gas leak in a building, you're not isolating power initially. You're isolating power when you realize there's a problem there. And just opening and shutting the door is going to cause a change in the thermostat, which could kick on the heat or the air. And just the thought that if you're entering to air monitor to do leak detection and the power is still on, shut the door. Do your best to control that atmosphere and don't let the heat or cool kick on there. And there's always the chance that electronics have battery backups, or you kill the power to the house and the smoke alarms have battery backups and the batteries in there are low and they start chirping. That's going to cause a potential ignition source there. On the responder side, encouraging that when they come out of their vehicle at a gas leak or they come out of their fire apparatus at a gas leak, that certainly their phone stays behind, but also their smartwatch needs to stay behind. That they're using a radio, that radio needs to be intrinsically safe. And if it's not, they need to have basically somebody in the middle to yell back and forth maybe to give information. If they're going to use a flashlight, and I strongly encourage anybody coming off a fire apparatus that's going to check for an odor of gas or a gas leak in a building to bring a flashlight with them that's intrinsically safe. We don't want to be inside flipping light switches. And the flashlight that you bought at O'Reilly's last week is probably not intrinsically safe. Make sure what you bring to this event is intrinsically safe and be in the habit of always having it. If it's 2 o'clock in the afternoon, the sunniest day of the year, that flashlight still may be needed inside of a building. So those are good ways to eliminate ignition sources. And also, I strongly encourage if they're approaching a building about to make entry, if they can find something outside to discharge static, go ahead and do so, just like pumping gas in the wintertime. And I had a suggestion I picked up this weekend over when we wore our firefighter protective clothing, our turnout gear. It typically Velcros. Your pockets Velcro, you have Velcro over your zipper on the coat. Just be mindful that if you're going to use something, have your pocket. We don't want to be in an environment open and shutting that Velcro potentially. If you think you need something out of your pocket, go ahead and take it out ahead of time. All great things to try to reduce the chance of an ignition. And I know that gets Dirk going there because his whole mission is eliminating static and understanding static and the discharge potential there that we face either while working on a gas line or responding to an emergency in a gas line. Next slide, Dirk. think this is one of the myths that when we do this in person, the looks around the classroom or the little light bulbs go off with this is if I look at the data, natural gas is lighter than air. Can't argue that. It's a scientific fact, right? The molecular weight is less than that of air. It's going to rise up. But there's a myth that natural gas is always going to be found high. First of all, you could have a leak in a subfloor or crawl space, and you may get your detection readings where it's coming through the floor. But bigger airflow and buoyancy can affect where your gas appears. If the air is on in a building or the heat's on in a building, warm air is going to rise, cool air sinks. It can move your lighter than air gas around a little bit. The picture on the bottom, we were training at Southern Company Gas's Leak Village. We were operating a leak on the stove in the kitchen of this little training house, and our LEL readings were all occurring at the floor. And it threw me off, and I asked the guy running the building, I said, "Hey, we had a leak on the stove, right?" And he said, "Yeah." I said, "Well, there's no leak in the subfloor here, right?" And he said, "No." He said, "Our leak's on the stove." The air was running in the building. It was a fairly small space. The return was low, and it was pulling the natural gas to the floor, and we were getting LEL reading at the floor. We weren't getting one at the ceiling because of the buoyancy of the air and being drawn back to the return. I ran a scenario at my department yesterday. I was using acetone as our source, so it was a heavy air vapor. I put some acetone in a closed room, and it was interesting. I always encourage before you go through a closed door, right? Air monitor around the door. See if you get a reading around the door. And they were getting LEL readings at the base of the door to the room. I expected that, right? It's a heavy air vapors where you should be getting them at. When they got in the room, their readings were lower on the LEL than at the door. And the best we could figure was where the air is being forced under the door, the heat was running in the building, so warm air was going up, cool air is being pushed down and pulled out the crack at the bottom of the door back toward the return. It was causing a concentration of the flammable vapors at the base of the door. So another funky thing going on there. This was a heavier air gas or vapor, so it wasn't really the same as natural gas, but you were still getting some concentration buildups because of the air movement. The other thing that can occur is in a hot, humid environment, which is where Dirk's at all year round and a good bit of the year where I'm at. And if you're in the Southeast, this could be a good bit of your year as well. When there's a building fire in a mid to high rise building, so 3 stories, 4 stories, 5 stories, 6 stories, 20 stories, 80 stories, whatever, you get the sink of cool air in those buildings, which happens in every place air conditioner or heat is always having a sink or rise of air going on. But in those buildings, you can very easily have a fire where the smoke from a fire on the fifth floor pulls down to the first floor because of the cool air bringing it down. The same thing can happen when we're capturing in natural gas. You can have a leak on an upper floor, but that reverse stack effect brings it down low because the buoyancy there is bringing it with it. It may help disperse it. It may build into a concentration, particularly pulling mercaptan through and spreading that smell very remotely from where the leak is. So just two things to, I think, really drum home when you're talking about looking for leak sources or getting air monitor readings indoors. There's still a habit, even though we know natural gas is typically lighter than air, we need to be metering at the floor, mid-level, and as high as possible in there. The other thing that I throw out here as a caveat is when somebody calls and reports the odor of gas, they may not know if it's natural gas or propane, and there are a lot of homes or businesses that have natural gas service, but also have propane cylinders present for griddles or grills or other things like that. We don't know which one they smelled. So doing a floor to ceiling air monitoring is a good habit to be in. Where I think that complacency can kick in is we go to a house or a building with natural gas service, our first thought is we want to look high for it. Don't discount looking low, middle, and high and having a good air monitoring habit there. Next slide, please, Dirk. This one is probably more of something for the the midstream and upstream operators, but we did see an operator that had written an emergency response plan a few months ago, and we were reviewing it with them. And they had provided their communications channels, their radios to the local fire department. And we pointed out that there's a good chance that you're on a different operating system, that the fire department could have an encrypted radio. You may be UHF, they could be VHF, they may be 800 megahertz, they may be a digital system. There are all a number of reasons why these radios can't talk to each other. And mainly on the upstream side, we haven't had this conversation much with downstream operators, but a lot of upstream operators have worked out plans with their fire departments where if there's an incident, a large incident anyway, is to come to the command post, their working unified command, to give somebody from the gas company one of their radios. So if they have somebody that's out giving feedback, they can communicate together. And just had a comment about Mercaptan being scrubbed. Absolutely. That's a whole nother slide, talking about we get the air monitoring over why the air monitoring becomes important because of the scrub of Mercaptan, that Mercaptan has a different buoyancy. There are a number of reasons why the odor may not be telltale to the source of the leak. Next slide, Dirk. Oh, go back one. So
There we are. Sorry, Dave.
no worries, no worries. In developing training, particularly with downstream operators, we have found some language differences. Was working on a training with an operator last year, and I'll be honest, myself and a guy from the operator, we argued for about 2 months over something, friendly arguing, not hateful arguing, but just friendly bantering there. But we couldn't figure out what was going on. To us, we were using the same word in a different manner. From a fire service standpoint, emergency response standpoint, the word evacuate to me means you empty the building out, right? You get everybody out of the building. And this is actually the next slide. I'm kind of foreshadowing here, but to him, evacuate meant when did his employees stop working in the building. So we had a pretty robust conversation over what LEL reading triggers that before we finally realized we're using it in a different sense. Here, the remote valve. Fire department curriculum, hazmat operations says that a operations level responder can operate a remote valve to stop the flow of product. That means you can go up and you can shut off the riser to the building. Then I can go, if there's a fuel supply, I can go hit the emergency stop button to the fuel supply. I can do something like that, operate the emergency shut-off valve on a fuel tanker. That's what that intent is. But in the pipeline industry, remote valve, you may call that a valve you can operate remotely, that somebody from your control center can operate via satellite communication or something like that. It's not really the same thing. And that's just a terminology when you're discussing remote valve, you may be using that word differently. Next slide there, Dirk. So certainly evacuation is the one that came up here. I'm talking about we evacuated. If there's gas in the building, we're evacuating. And he's saying, well, we evacuated 50% of LEL. And their operators now changed to 20% of the LEL, I believe is what they switched to. By the time they were doing 50% to pull their people out of the building. And I said, we're evacuating at any gas. But he was referring to evacuating his employees, where I was referring to evacuating the occupants of the building. And we finally came to it. We're discussing when you evacuate a hospital, which is very difficult to do. And we realized we're using the words in a different sense. The word occupancy, from a fire service standpoint, the word occupancy means what's the building used for. For most people, the word occupancy means what's the number of people in it. And then exposure. The strip mall there is a great example. In fact, we had two gas leaks in strip malls yesterday, which is the example I love using when I teach about this. From a fire service standpoint, an exposure is another building or something that's being affected by the incident. So typical strip mall in the United States, Chinese or Mexican restaurant in the strip mall, there's a nail salon, there's a tax prep place, there's a vape shop, things like that. Most strip malls are built on a concrete slab. They're very interchangeable, right? They can take a stud wall out and make one occupancy into two. There's a common void space across the top with a drop ceiling. And very likely, and if you're in the distribution side of this, you've encountered this, I'm sure, you get a call first thing in the morning, 8, 9 o'clock, to the the nail salon to the vape shop, something like that. And you go in there and you start looking for your leak source. You get a reading above the drop ceiling. Again, we want to encourage getting the reading as high as possible. So above the drop ceiling in the attic is are key places to get readings. And you realize you have a gas reading, you have an LEO reading that's running that void space up there. And we find the leak source to be in the Chinese restaurant, the Mexican restaurant, or another exposure down that strip. We had two of them yesterday that did that, and both were originating in pizza restaurants. Just kind of ironic they both happened yesterday when we talk about this, but it's a fairly common thing that occurs. So when using the word exposure, for sure, understanding what we mean with each other. So that may be a conversation. If you're doing liaison work and you're talking with somebody and a word comes up, just just pick a word and say, hey, what's that word mean to you versus to me? And just see if there's a difference there. But particularly evacuation, occupancy, exposure, remote valve are words that we've identified can be mixed up and jumbled up just because we use them interchangeably and differently at the same time. Next slide, Dirk. So, big myth, every fire department has air monitoring. A lot of fire departments in the United States do not have air monitoring equipment. Um, So use of the sniffer is very common. And I go around the room and ask, who's been in the fire service the longest? And, have you ever used your sniffer to make a decision on a scene? And I'm honest, I've done that. I've made a decision using my 1980 model sniffer there. Um, Dirk, what year model is your sniffer?
Too old,
Too old.
obsolete.
Obsolete. When's your last calibration on your sniffer here?
I can't remember. It's not
See?
pretty any good
Yeah,
anymore.
okay. Well, there we go. Um, and I talk about how we love to use um, words to describe things. We have a heavy odor. We have light smoke coming from a building. We have heavy smoke coming from a building, but they're still very subjective. And there's no way that the sniffer can go in there and say, man, this is a lot of gas in this building. I can't quantify that. And I want people to understand they can't quantify that. But do we use our sniffer? Yeah. Hey, I have an odor mercaptan here. I can't say we don't use it, but the decision has to be from electronics. And like in the comments there, we can't say there's no gas if the sniffer doesn't smell something because it could be scrubbed out. We could have a separation, right? The mercaptan and natural gas or mercaptan and propane are not chemically bonded. They're sharing a space, and the mercaptan is going to be roughly neutral. So it comes up here to sniffer level, but natural gas could be above us, propane below us. Natural gas can be at a higher concentration somewhere else, and the mercaptan is settling down to us. Any number of things there while using the sniffer is not reliable, and electronics have to be used. And a strong encouragement if you're doing liaison work and you have a fire department that does not have air monitoring capabilities, is strongly encouraging them that you're not making decisions with a sniffer. And aside from telling people to get out of a building, you shouldn't be looking for a leak source using your sniffer because you can really get yourself in trouble. We can't tell how much gas is there, and a strong encouragement over wait till that capability shows up. In our state, in our Perry program, we are fortunate that we have funding that we provide air monitors to fire departments that don't have them. We kept getting feedback over. We talk about air monitoring, talk about use of air monitoring on gas leaks, and a lot of fire departments don't have the capability. And it leads into the slide the myth on the next slide here. Hit it up, Dirk. That good air monitoring training is available. It's not. It's a rare thing to find good air monitoring training in the fire service and industry. You can. I was teaching this weekend in Texas and had a lady in class who she's a volunteer firefighter, but she had a background in industrial hygiene. And we had a great discussion over air monitoring for industrial hygiene, or if I'm working in a confined space, if I'm working in a plant and I'm wearing an air monitor, I'm typically waiting on the air monitor to beep to tell me I'm in an unsafe area for work. Where when I'm looking for a leak source, I'm trying to interpret what's going on. I've got to be watching the meter and see what the readings are doing, looking for trends, looking for a yes or no presence, which is vastly different than walking around with the meter clipped to my belt, waiting on it to beep. And I used to say that when a fire department ordered an air monitor, the salesperson would deliver it and give them a training on how to calibrate, tell them how to change the battery. And that was really the end of it. There was no class on how to properly air monitor and what you're looking for and how to interpret the readings. But today, there's a good chance it's being purchased online, and there's not even a delivery speech from the salesperson. It just shows up in a box from Amazon or wherever you buy it from. And if we're not careful, we walk around, we're doing this high, middle, and low um, air monitoring, and we really want to look at a drum major because our hand is only going from the top of our head to about our waist, doing high, middle, and low, like the drum major leading the parade there. High is as high as we can get, low is as low as we can go. Um, where you work at, I'm willing to bet there's still shag carpet. If we're looking low, that meter needs to get down to the shag carpet. This past summer, we were looking for a way to kind of give an example and a visual over what goes on when we're looking um, with a CGI for natural gas. My friend John Holton, he put in ChatGPT, what's the difference in 5 and 15%, which would be the flammable range of natural gas. And ChatGPT told him that is roughly the difference in a grape and a grape and a grapefruit. So I tasked my daughter, who is 8. She turns 9 in about 4 days. She's listening to me right now, but she's not really paying attention. She turns 9 in about 4 days. I encouraged her to come up with a way we could demonstrate this, and she drew a diagram of ants investigating a picnic. And she likes to play with air monitor. She likes hazmat. We saw her earlier with the locate marks there, and we discussed that an LEL sensor on a 4-gas meter has a no detect level of maybe 1 to 2% of the LEL. So there's a limit it can't read below. So another encouragement there is when you're doing liaison work is just because they have 0 LEL on their meter does not mean they're free of gas. Another reason why the operator needs to be involved, the operator needs to be contacted is there's a no detect limit on their meter that it can't see below, where with a typical CGI, we can get readings down to maybe 1/10% of the LAL. We can see very, very small leaks with a CGI. So she used a blueberry as her detect limit there. So her demonstration is, and the ants at the picnic discovered this, that they're reading from the blueberry to the grape. So from the grape to the grapefruit's the flammable range, and from the grapefruit to the watermelon is above the flammable range. So in the UEL there. And just a great way that if you're going to do a demonstration and you're showing air monitor to somebody, that's a great scalable thing you can lay out for them. And it's fun. You can eat the fruit afterwards too if you want to. Next slide, Dirk. So there's a myth out there that responders will always contact the operator. And I've been fortunate to teach a lot of places in my state and a lot of places around the country. And this is always a conversation that I make sure I have. I've had people say, "Oh, well, I don't want to disturb the operator. If I don't find a reading of gas, we don't have an odor. I don't want to bother them." I'm like, "No, that they want to be contacted. They want to be notified something's going on. They want to come investigate it themselves. Their meter may be able to pick up things you can't. They may look for leak sources that you're just not thinking of, right? More brains are better than, 2 brains are better than one, 2 meters are better than one, whatever the case may be, let them know so they're aware they can document things like that. The picture on the left over there, I know it's hard to see on the screen. I pulled it from a fire department in Northern Virginia, and it said that, we will call the gas company, you know, 24 hours a day, 7 days a week, 365. I'm assuming they call on leap day 2 and February 29th. Kind of tongue in cheek there, but it says they'll always contact the gas company. And then right under it in small print, it says if there's no odor, no readings on our meters, we'll go back in service, but they don't call the gas company. They only call the gas company when there's an odor or meter reading present. And I really wanted to just write them and say, think about what you're putting out here. You could easily miss something just because of human nature or whatever, and set yourself up for liability because you didn't call the operator. I also encourage, just like an operator should do, that the fire department start the leak survey outside, right? We're starting with the sewer manhole. We're starting with the storm drain, work our way toward the building, eliminating the possibility of migration before we ever go in the building. A lot of response plans are written in a linear fashion, but we have to teach them they can occur non-linear, right? And I was teaching this, and somebody said one day, well, why wouldn't you evacuate the building first if there's no odor inside? I said, well, we would. If I have 2 or 3 people, I may send one to start getting people out of the building, while one air monitors. We can do things simultaneously. So it's also an encouragement that just because your process is written in a linear fashion, things can happen simultaneously. You don't have to do it step one, then step two, then step three, um, and so on. My daughter asked me a question. My apologies there. So make sure that's known, but also just because you're not getting it doesn't mean there's nothing there. I encourage to take a soapy water bottle to the gas meter with you. Spray the gas meter, look for bubbles. Or there could be a slight leak that you're not getting in your meter because the wind's blowing it around, but it's enough that they're getting an odor through the soffit or something like that. So just strong encouragements over ways to look for that leak source, but 100% the responder always needs to contact the operator. Next slide, please, Dirk. So here's our linear process in a non-linear world. Um, again, most every response plan, most every training is written in a linear fashion, and we're not going to linear events. We really encourage use of the OODA loop. The OODA loop was developed, if you're not familiar with it, by Colonel John Boyd of the Air Force. When John Boyd was in high school, he was told that with his IQ, he wouldn't really do much in life, for lack of better words there. He wound up writing curriculum and doctrines for fighter pilots that are still used today in fighter pilot training. So not bad for a guy that's told he wouldn't amount to anything. One of the big things he wrote was the OODA loop. There's some great TED Talks on YouTube. There's some books on how to utilize the OODA loop. If you run safety programs, you run decision making, I would strongly encourage looking at adding the OODA loop into what you do. And especially you observe what's going on, you orient what it means to you, you decide on the best action to take, you carry out the action, and then you start the process over again, right? If we're ventilating or conditions getting better, if we shut off a valve, do we see a change in conditions, things like that. But it can go into a number of different processes or things you do in any business. The picture on the right is from Youngstown, Ohio this past spring. A contractor, from what we've gathered from the report so far, the initial findings, a contractor was working in the basement. The contractor cut through a gas line in the basement they had been told was inactive. Gas starts escaping. They pulled the fire alarm on the building. Well, the fire alarm, that's a potential ignition source, but that was the best way they could notify the building that something was going on. In a high rise, and I'm not sure the case here on the height of the building, how the alarm system was set up, but a lot of times in a high rise, you have a zoned alarm. The alarm only goes off on a number of floors. You could easily be staying in a hotel that's 24 stories high, have a fire alarm in that building, you never know it because it only alerts the floors close to where that alarm is versus alerting all 24 floors. I'm not 100% sure how the alarm system was set up in this building. About 6 minutes later, there was an ignition. There were employees from the bank on the first floor. One was killed. There were other employees that dropped into the basement of the building. The fire department showed up. They made rescues out of the basement. There's some body cam footage from a cop on YouTube, and the cop is thinking this is a, a criminal act, and he's saying, "Watch out for secondary devices." He's following his training there. There's maybe not the best PPE usage going on in the video, and I'm not here to talk about that or judge that or get into that. But if you're watching that, don't get hung up on the PPE, but use that in a teaching conversation later. But when this first happened, I had several folks from the distribution side, the downstream side, say, none of our response plans account for this. And I encourage firefighters when they're responding to an odor of gas indoors or a gas leak indoors to expect it to be on fire, to expect victims to be inside. We hope the PSAP, we hope the 911 center has told them to evacuate, but be prepared in case they haven't, and to expect the front door to pass you coming down the street or down the driveway. That their mind has to be, I'm potentially going to a fire here. I need to be ready to deal with that when I show up to get people out, to start suppressing fire, things like that. Don't take the approach over, oh, this is just a faint odor of gas inside and there's no danger. Show up thinking that there's danger here because that's why they called us. And I think they did a great job in Youngstown of making the rescues they did. It's just most of the linear processes don't account for the fact that the building has lit off or had an explosion before you show up, and they've got to be prepared and in the mindset to deal with that. Next slide, please. Um, Probably more for the upstream operators, but there's a belief that every community has a local emergency planning commission, and Most communities don't, and a lot of them aren't active. But if your community does have one, I encourage you to be involved in it if you're not. And if you are involved, I encourage you to find ways to make them active and make them proactive in pre-planning and conducting drills, things like that. Next slide, Dirk. Traditional training doesn't always work. Traditional liaisons sometimes may swing by on a Tuesday at 10 o'clock, and it's a volunteer fire department. You may or not may or may not find anybody there. Trying to have your liaison meeting during the week in the daytime in those areas doesn't work very well. You've got to go to them when they meet. Find out when they meet, or host your training, host your drills in the evenings or on Saturdays, and you get a much better result there. The drill on the right there, um, it was asked of the fire chief, and this was an upstream operator conducting this drill, how would he do something? And why is he doing it this way? And he said, because you're doing this drill at 10 o'clock on Tuesday morning, and every one of us took off work to be here, and I couldn't call my mutual aid resources in because this isn't an actual incident, so I'm working with way less than I would have for this drill. That's why I'm doing it this way. And I've done drills with operators where they called with about 3 weeks notice and said, hey, we want to do a drill on Monday morning at 10 o'clock. And it is very much a check the box drill versus actually looking for a relationship building and what would you do in this response and how would you handle this and really testing the system. So in some areas, 10 o'clock on Monday may work wonderfully. But give enough time to truly plan a drill out and plan out what your goals and objectives are to accomplish. But if you're in a volunteer fire coverage area, or mostly volunteer fire coverage area, an evening drill, evening meeting, a Saturday drill, Saturday meeting may work out way better to get your message to people and to promote what you're talking about. And a lot of drills don't account for the nonlinear. So find ways to build those nonlinear decisions in there, but you need enough people in the drill where they can do things simultaneously versus step one, step two, step three, step four, like that. Next slide, Dirk. There's not a good understanding of evacuation versus shelter in place out there. Curriculums talk about it, but they don't really describe it very well. Make sure people understand that evacuation is what we need in flammables, that shelter in place is probably not always the best option for flammables. But if we get into places hard to evacuate, like hospitals or places, things like that, we may choose to shelter in place from an outdoor leak, but the fire department may be putting water streams up to move vapors away or gases away from the building, things like that. Really have a conversation over deciding to evacuate and how to do that, right? The picture there is a gas leak in front of a hospital. Most definitely, you're not evacuating the hospital easily, but what can a fire department do to keep that gas from getting in the hospital? I said, putting water streams up, fog streams up will help move the gas away, and that may be a protective measure. How do we get air monitoring in the building? What do we shut down in the building to keep control over where the gas may spread? Things like that are conversations certainly to have. Next slide, Dirk. How do you do notifications? What in your local area is there for notifications? A lot of emergency management agencies use different systems. There are multiple apps or things out there that they can use, and sometimes one county uses one app, the next county uses a different app. And so if you're traveling through, you may not get the message. They do have a system nationally called iPause, where they can capture all mobile devices. How do they activate iPause? How do they use it? Some places the local government can access iPause. Some places they have to go through the state to do it. If you've ever done evacuations, you know that door to door is very time consuming and very tricky. And one thing that I'm trying to encourage that we encounter is prevalence of like a Ring camera, like a Ring doorbell. That I encourage the first question you ask when you get to that is, "Are you home?" And if they're not home and nobody's home, we're moving on to the next one versus having a 2 or 3 minute conversation with somebody that's 100 miles away. And we've encountered that we're trying to evacuate and we're going through this whole conversation. And wait a minute, you're not here, nobody's home, we're moving to the next building. We've lost time on this. Or secondly, if they are home, hey, come to the door. Instead of us having this conversation via Ring, come to the door because I don't want you sitting in there in maybe a bad environment if we have migration going on talking to me through electronics. I want you coming out and speaking now. Next slide, Dirk. We always have traditionally taught that if there's a fire, all the gas is burning up. Well, in the case of migration, that's obviously not true. The only gas burning is above the surface. What's spreading below the surface is not burning. That needs to be a big understanding. Again, in the expanded version of this, we give some examples. We go a little more in depth in this. We're just kind of short on time today to go deeper in these examples. But again, I encourage you, if you want this, we can do it by Zoom. We can do it in person or work on that. Certainly reach out. Uh, There's a myth that resources are consistent fire department. That is certainly not true. I was telling Dirk earlier that the way you would approach a response plan in Houston is vastly different than you would approach it in Bell Buckle, Texas. Two different resource capabilities there, two different impacts potentially, and you have to kind of adapt your message to who you're talking to that day and what their capabilities are. Encourage them if they need mutual aid, they need other fire departments to come help them to certainly call for that. But there's a big difference out there. And the next slide, Dirk. There's a belief out there, among a lot of people, that the operator will handle everything. This is a joint response. When I joined the fire department and we went to a gas leak, it was almost like the operator had cooties. We didn't talk to each other. We may sit on the front bumper of the engine, probably not even wearing our firefighting gear, and we would watch them and it'd be like, hey, they're here. We may sit around and watch. We may say, hey, they're here. Peace out. See you later. Bye. It's their problem now. And it's not the operator's problem. It's our problem together, right? If we can provide air monitoring, if we can put a hand line on the ground while the operators, folks are working in the hole, we can stand by with a fire extinguisher in case there is a fire they need it put out. We do a metering survey. We do a perimeter every 5 or 10 minutes to check for migration to allow the operator to work and fix the problem there. Next slide, Dirk. Once again, this is the QR code for Buxus. If you want to shoot me an email and talk more about it, you certainly can. It's in the chat, but also my email address is flames64.db@gmail.com. And I guess we have a couple minutes there if we had any questions in the chat or.
Well, David, I want to thank you for this again. If you want to chat some questions to David, please feel free to do that. Remember that you will get an email with a link to the recording of this. We appreciate, David, you taking the time to do this. You know, this is something we can bring around the country and people don't have to travel. It's very kind of you to do this. You bring a view from the other side of the response, other side of the incident, which is very valuable. So, is there any other chat questions you see there, Dave?
I see Dave Baldinger brought up a lot of good points there, and they've also switched to black line safety for their meters, which is an interesting sensor technology. It is a different LEL sensor than what you typically find in a CGI or a sensor you would find in a 4-gas meter. It is very sensitive, and it's picking up things, like he says, sometimes before they're getting them on their CGIs.
Dave, you're going through the chats?
Yeah, pretty much everything was a comment from Dave there, just kind of support what we're talking about don't just check the box when exercise, build relationships, and their challenges with their lone worker program, and the difference. Understanding what meters for what. So they're using the black line for lone worker. They're still using the CGIs for their leak detection, things like that. So good deal, everybody. Thank y'all.
Well, again, thank you, David. Thank you all for being with us, and be looking for the link to the recording. So with that, we are going